Hi, I'm Ziling, and this is milestone one for the SE576. I start by showing the convert project. Let me first run the convert under the release mode. There are quite lots of files to process, yeah, so it takes a bit of time. Okay, I reorganize the whole project, so everything is grouped uh, by what is being converted for. So I now have animation converter, mesh converter, the texture, XM converter, and so on. I also pulled it out to the shared paths and the common libraries from this uh, uh, source files and put them into this full category, which makes the whole project a lot clearer and easier to navigate. So in the main functions, I converted all the textures, the meshes that the engine needs. I'm using three animations here: the chicken boat, the dog boat, and the spider boat. For each of them, I converted the textures and bone meshes, skeletons, and also the animations in main. I also added the conversion for the 2D font part of the engine. Okay, right, this converting is finished. Next, let's take a look at the engine. First, I run the code to show the result. Okay, and you can see here the every 3D model has its rate sphere displayed. I can press T to toggle it on and off, just like in the previous version of the project. And in the 3D model section, you can see the R2D2 models on the top, one with textures applied and another in the wireframe mode. At the bottom, there are two simple 3D models, a crate and a frigate. There are three D animated models, the chicken boat, the dog boat, and the spider boat. And each one has a corresponding 2D font label that shows its mesh and animation type. I can press the space key to switch the animation, as well as the font for each model. Yeah. And I also added green birds and white birds and the 2D sprites. The system uses two sets of cameras, 2D camera and 3D camera. The 2D camera stay fixed on the screen. So when I move the 3D camera, the 2D sprites remain static while the 3D models change position based on the 3D camera transformation. I can zoom in and zoom out, and I also can rotate the camera, and you can see the models rotate accordingly. Let's reset it. Uh, this behavior is definitely enabled by the dual camera setup. Okay. Finally, let me show you the code. Everything here is fully data-driven. So in the node content method, I first create all the manager classes, and I set up both the 3D and 2D cameras, register them with the camera manager, which can automatically apply the correct camera to the corresponding 2D or 3D models. And these are the shader defines that the model will use. Here I deserializing different kinds of meshes from the protofiles, including three animated meshes. All of the meshes are then added to the mesh manager. Next, I deserialize the model textures. Yes, I also generated the 2D sprites images as well as the front textures and their XML from the protofiles. After that, I think all the game's objects are loaded into the uh, game object manager, which will handle updating and drawing for the 3D models. And for the 3D animated models, there are a few steps, additional steps. So uh, we need to deserialize the skeleton and clip profiles, then create the animation objects, and there are controllers here. The animation controller is responsible for updating all the animation clips. So look at the code structure. I also reorganized the shared paths of the object, similar to what I did in the converter project. This makes the code much cleaner. To support the 2D system, I added the sprite modules and the front modules. And for the 3D animation, I added the skeleton and the clip modules, and also I updated the animation modules. That's it for milestone 1. Thank you.